Hey everyone, welcome back to the P5 series. Uh, this playlist is dedicated towards the permutations and combinations. So last year we covered 2010 and 2023 and some questions from I think 2022 also. So we'll resume this uh, from the year 2011. So let's see the first question that comes up. So this is May, June 2011, 6-1, question 4. A cricket team of 11 players is to be chosen from 21 players, consisting of 10 batsmen, 9 bowlers, and 2 wicket keepers. So this information is absolutely important. Team must include at least 5 batsmen, at least 4 bowlers, and at least 1 wicketkeeper. That means 5 or more batsmen, 4 or more batsmen, and 1 or more wicketkeeper. Find the number of different ways in which the team can be chosen. So chosen means this is a combination problem, not a permutation problem. So since we need to choose, we need to make a selection from batsmen. We need from bowlers and from wicket keepers. I'll just write them as wicket keepers. So batsmen, we need at least 5, at least 4. So let's say we go with that 5, 4. And since we need 11 players, 5 plus 4 becomes 9. So that means we need 2 wicket keepers to finish this combination. Similarly, let's say we take 1 wicket keeper and 6 batsmen. So that would make this, we would need, oh no, sorry, no. No, sorry, 4. My bad, 4. 4 would suffice. Similarly, if we keep it 1, we increase one of the bowlers and keep 5 batsmen. Right. So just to go over our options, we increase 1 wicket keeper, we increase 1 batsman, and we increase 1 bowler. So all of these, the total are 11. 5 plus 4 plus 2, 11. 6 plus 4 plus 1, 11. 5 plus 5 plus 1, 11. Now, the combinations themselves. So we have 10 batsmen, so we are choosing from 10 batsmen only 5. Similarly, from 9 bowlers, we are choosing 4. From 2 wicket keepers, we are choosing 2. Similarly, 10C6, 9C4, and 2C1. Similarly, 10C5, 9C5, and 2C1. So these are the different combinations. So we will take their totals, we will take their individual numbers and we will add them because these are the different possible combinations that we can have. So total. So let's calculate them. So 10C5 times by 9C4 times by 2C2. We get 31752. 10C6 times by 9C4 times by 2C1, which is going to be just 2. So 52920. Similarly, 10C5 times by 9C5 times by 2C1. So 63504. Now, for the total, we just need to add them back up. So 31752 plus 52920 plus 63504. 176. Now, each player in the team is given a present. The consists of 5 identical pens, 4 identical diaries, and 2 identical notebooks. Find the number of different arrangements if they are all displayed in a row. Now, the keyword over here that they're using are identical. So we have to use that identical scenario, identical items scenario over here. So total items we have are 5 plus 4, 9, 9 plus 2, 11. But we have 5 identical pens, 4 identical diaries, 2 identical notebooks. So 11 factorial divided by 5 factorial, 4 factorial, 2 factorial. Oh, sorry. Oh, sorry. I forgot the multiplication signs. 6930. Now the third part. 10 of these presents are chosen and arranged in a row. That means one of these 11 is missing. Find the number of different arrangements that are possible. Okay, so we have, what was it? Pens, diaries, and notebooks. Okay, so pens, diaries, notebooks. So we can choose different ones. So we have 5 pens. Let's say we have 5 pens, 4 diaries, and 1 notebook. Let's say we have 2 notebooks, 3 diaries, and 5 pens. Let's say, so just to, make sure that we are doing this, we have 5 total pens, 4 total diaries, and 2 total notebooks. Okay, so we can drop 1 pen and we can keep the diaries the same. So that would mean that we need 2 more notebooks. Right. Okay. Now let's make the combinations. Okay, so the combinations for this, they are going to be slightly different. So let's make them like this. Because we have identical pens, we have identical scenarios, so we have to be a little bit careful. So for this one, this is going to be 10 factorial divided by 5 factorial, 4 factorial, and 1 factorial is just 1. Because we have 10 presents and 5 of them are identical pens, 4 of them are identical diaries, and so on. Similarly, 10 factorial, 5 factorial, 3 factorial, 2 factorial. Similarly, 10 factorial, 4 factorial, 4 factorial, 2 factorial. And once we have each of these, we will just sum them at the end. Okay, so let's figure this out. So over here we have 10 factorial. So the first one is just 5 times by 4. So 1260. Second one, instead of 4, it's 3 and 2 factorial. Okay, 2520. Similarly, we have 4, 4, and 2. So this is 4, this is 4. So 3, 150. So plus 2520 plus 1260, we get 6930. Wait. Oh, okay. Now, uh, right. Yeah. So basically, these are the arrangements. Because we needed arrangements, so we are doing the permutations over here. We don't have to choose because we have identical items. All right. So basically, that was this question. So let's do the next one. All right. So other variant. First question. Find the number of different ways that the 9 letters of the word happiness can be arranged in a line. Okay, so what we notice over here that we have two P's, two P's. Basically that means identical, and two S's. So if we want 9 letters arranged, that would be 9 factorial divided by 2 factorial divided by 2 factorial. So 9 factorial divided by 2 factorial divided by 2 factorial, and that would be this 90720. The 9 letters of the word happiness are arranged in a random order in a line, and find the probability that the three vowels A, E, I are not all next to each other. So what we can do over here, we can find out the number of times that they are together, and then we can subtract from this value, and then the probability. So number of different arrangements when vowels are together. So what happens is that when you take away the A, E, and I, you are left with H, P, P, that means two identical P's, N, S, and S. So we will still have the identical cases, and A, E, I are basically in their own one unit by themselves. So we have 1, 2, 3, 4, 5, 6, and then seventh unit itself. So we still have 7 units. We have two pairs of identical P's and S's. And inside this AEI, we can have different arrangements also. So times by 3 factorial. So this would be 7 factorial times by 3 factorial divided by 2 factorial divided by 2 factorial is just 2, so we can just leave it like that. So 7560. Now the probability when they're not together, so probability um, that vowels are not together, we will just take away them from the total. So from the total, that was 90720, we subtract the times that they are together, 7560, divided by 90720. So 90720 minus answer divided by 90720. So 11 over 12. I think we can leave it as 11 over 12, but you could write it as um, 0.916, three significant figures. You can write it as 917 also, absolutely fine. 917. I think 11 over 12 would be fine also. All right, now the part 3. Find the number of different selections of 4-letter words, different selections this time. So see uh, combination thing of 4 letters from the 9 letters of the word happiness, which contain no P's and either 1 or 2 S's. Okay, so let's write the word over here so I don't forget. So HAPPINESS. So that means we do not have access to these two, and we have either one S or two S. Okay, so when we have one S, the combination will look like 5C3. Simple 5C3, because we are already selecting one out of two S's, and those are already identical. So when we have 2S, so 2S already there, that means you have, for example, out of those HIINES, one of the S's are already there. If we have two S's already there, that means the selection that we can do, like out of these 5 letters, we can only choose two more. So that would be just 5C2. So 5C3 and 5C2 both are the same number, so 10, 10. So we will get total equals to 20. Very straightforward. All right, so I think that was it. So let's see the third variant for the May June 11. Okay, so let's see this question. So Fahad has 4 different colored pairs of shoes and 3 different colored pairs of jeans and 7 different colored t-shirts. Okay. Fahad chooses an outfit consisting of 1 pair of shoes, 1 pair of jeans, and 1 t-shirts. So how many different outfits he can choose? So this is a choose question. So from 4 colored shoes, from 4 colors of shoes, he can choose 4C1. From 3C1, and from jean t-shirts 7C1. So it's basically just 4 times by 3, 7. So 4 times by 3 times by 7, 84. Now, how many different ways can Fahad arrange his 3 jeans and 7 t-shirts in a row if 2 blue items are not next to each other? So we have, jeans. Let's write it first. So we have jeans 3 and t-shirts we have 7. Okay. So out of these, we need to arrange them in a row such that the blue items are not next to each other. So what we can do over here, there are 2 ways we can find a total number, random order, and minus those with those instances when they are together. However, there's an easy way to handle this also. So we have 3 genes, like 2 genes, 6 t-shirts that are not blue. So these are not blue. Blue ones, since they don't have to be next to each other, so they can take this place, 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 and this place. So 1, 2, 3, 4, 5, 6, 7, 8, 9. One of them can take 9 places. So if, for example, if we use blue jeans over here, this place is gone. So for the blue shirt, you have 8 choices, which can also be written as 9P2. Absolutely fine, whichever way you want to write it. So the rest items are just simply 6 plus 2, 8. So 8 factorial, 8 factorial. So 9P2 times by 8 factorial is just equals to 2903040. Okay. Fahad also has 9 different books about sport. When he goes on holiday, he chooses at least one of these books to take with him. How many different selections are there if he can take any number of books, ranging from just one of them to all of them? So this is an interesting question. So he can take one, he can take two, he can take three, up till he can take all 9 of them. So what we can do over here, it's 9C1 plus 9C2 plus 9C3, and it will carry on up until 9C9. So rather than typing all of this in the calculator, we can just use the symbol sum. 9CR, R starts from 1 to 9. So we have this symbol in the calculator also, this symbol. So 9C, over here it's X, so X, that will be. X goes from 1 to 9. We get 511. All right, so these were the May, June questions. Now let's see the October, November ones. See this. Part A, find the number of different ways in which 12 letters of the word strawberries can be arranged if there are no restrictions. So if there are no restrictions, remember that either way, let's say before we start this, we have 12 letters word, but we have 2 S's, 3 R's, and 2 E's. So even if there are no restrictions, we have these identical items. So that would be just 12 factorial divided by 2 factorial, 3 factorial, 2 factorial. So 2 factorial is just 2, and 3 factorial is 6. So 2 times by 2 times by 3, basically. No, sorry, 6. 24. So 12 factorial divided by 24. So this is the value. 1995840. All right. Now, if the vowels are together, okay, so if the vowels are together, then we have how many items? So 12 minus 4 would be the consonants. So if vowels are 4, then consonants will be 8. So the total units that you're arranging are 9. So 1, 2, 3, 4, 5, 6, 7, 8. And ninth unit will be the one with the A, E, E, I. The rest of these will be over here. So S, T, R, W, B, R, R, S. So notice that we still have three R's over here and with a different pen, two S over here, and also two E's inside that. So we have 9 units to arrange. Out of those 9 units, we have 3 R's, 2 S's. And inside this unit over here, we have 4 items, but 2 of them are identical. Okay, so we just have to do that. So 9 factorial times by 4 factorial divided by 6, 2, and 2, again 24. So this is the value. 3, 6, 2, 8, 8, 0. Four astronauts are chosen from a certain number of candidates. If order of choosing is not taken into account, the number of ways the astronauts can be chosen is 3876. So we don't know the total number, but we do know that we are choosing 4 astronauts. So we know NC4 is equal to 3876. How many ways are there if the order of choosing is taken into account? Okay, all right. Then that means we need to find out NP4 instead. Okay, so B part 1. We can talk about the formulae also. So for when we have NPR, the formula is N over N minus R factorial, whereas NCR has one additional thing. So N factorial, N minus R factorial, R factorial. You could also say that this is NPR over R factorial. So that means that NC4 is going to be equal to NP4 divided by 4 factorial. And NP4 is what we need to find out. So NP4 is equal to NC4 times by 4 factorial, so which is just 3876 times by 4 factorial. So 3876 times by 4 factorial, 93024. All right, now let's see. 4 astronauts are chosen to go on a mission. Each of these astronauts can take 3 personal possessions with him. So 4 astronauts and 3 possessions per person. Okay. How many different ways can these 12 possessions be arranged in a row if each astronaut's possessions are kept together? Okay. Now what we have over here is that each person's possessions are kept together. Okay, so the units that we have are 4 basically, so 4 factorial, but inside we have 3 factorial, 3 factorial, 3 factorial, 3 factorial. So like this. So the order of arranging the astronauts is 4, but their presence inside those arrangements are 3 factorial each. So like you can also write this as 4 factorial times by 3 factorial raised to power 4. So um, so 4 factorial is basically just 24, and 3 factorial is 6, so 6 raised to power 4. So how is 4? So 4 times by 3 times by 2 times by 1. So that. So 24 times by 6 raised to power 4, we get 31104. And that's your question. Now let's see the 6-2 variant. All right. So 12 coins are tossed and placed in a line. Each coin can show either a head or a tail. Find the number of different arrangements of heads and tails which can be obtained. So this is very easy. So we have 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And each of these have two choices. We can have either head or a tail. So 2, 2, 2, and so on. So basically 2 raised to power 12, because each of these has two choices. So 2 times by 2 times by 2, basically. So 2 raised to power 12 is 4096. Now, the second part. Find the number of different arrangements which contain 7 heads and 5 tails. Now, you see that the keyword is different arrangement, just like over here we had different arrangements. But 7 heads and 5 tails are identical items, like 7 identical heads, 5 identical uh, things, or tails, sorry. So we still have 12 things to arrange, but out of these are 7 heads and 5 tails. So 12 factorial, oh, sorry, 12 factorial divided by 7 factorial divided by 5 factorial. So 792. Simple. This was a very short question. All right, so now let's see the 6-3 variant. All right, so let's see this. So Mary saves her digital images on her computer in 3 separate folders: family, holiday, and friends. Her family folder contains 3 images, so let's write it before we forget this. So family has 3 images, friends uh, folder has 8 images, and holiday has 4 images. Okay. Find in how many ways she can arrange these 15 images in a row across her computer if she keeps the images from each folder together. So that means these 3 together, these 8 together, and these 4 together. So 3 factorial, 8 factorial, 4 factorial times by the arrangements of these albums themselves. So that would be 3 factorial. So times, times, times. So basically that would be simply equal to 3, 3 factorial is 6, that is also 6, times by 4 factorial is 24, 8 factorial, we can just simply do that. So 6 times by 6, 36, times by 24, times by 8 factorial, that would be this number. That is 34836,480. Now, find the number of different ways in which Mary can choose 6 of these images if there are 2 from each folder. If there are 2 from each folder, so that's very easy. So 2 out of 3 from family, 3C2, 2 out of 8 from friends, and 2 out of 4 from holiday. So 3C2 times by 8C2 times by 4C2, 5 and 4. Now let's see the third part. Find the number of different ways in which Mary can choose 6 of these images if there are at least 3 images from friends folder and at least 1 image from the other 2 folders. Okay, all right. So basically we have 3 or more for friends. So friends we have total 8. Family and holiday are 1 or more each. So family are 3 total. Friends are no, sorry, holiday. 4. Okay, now we can make the combinations. All right. So 6 or more. Sorry, no, 3 or more. So let's go with the easiest one. Let's say we have 3 friends and 1 from family, and the rest can come from holiday. 2. Similarly, if 3 from friends, but 2 from family, 1 from holiday. 6 total. Yeah. Similarly, since we can have more them, so 1 from each and 4 from friends. And I think that concludes it. There's no more possibilities, right? Yeah, okay, all right. Now we make the combinations. So 8C3 times by 3C1 times by 4C2. 8C3, 3C2, and 4C1. Similarly, 8C4 times by 3C1 times by 4C1. So now we just need to get their numbers and add for the total. So 8C3 times by 3C1 times by 4C2, 1008. 8C3, 3C2, and 4C1, 672. And 8C4, 3C1, and 8C4, 840. So now we just want to add up these. 672 plus 1008, 2520. And that concludes this question also. So these are the year 11 questions. Hopefully in the next video we will cover the 2012 and moving on. All right. So if you see any problem over here, if you think I made a mistake somewhere over here, feel free to reach out, comment. And I hope this video helped you. So like, subscribe, and share this with your friends. All right. So take care. Bye-bye.